Welcome to today's Explainer. We're diving into a story that is absolutely going to redefine how we think about the software running our entire world. I want you to picture this, okay? It's just a regular, quiet Tuesday deep inside Microsoft's main campus. There's this routine internal security dashboard up on a monitor. It's the kind of panel that normally just scrolls by with the occasional blip, completely unnoteworthy, right? But on this particular Tuesday, the numbers on that dashboard suddenly start to spike. Something entirely unprecedented is happening. Let's get right into it.
Wait, is that right? That is exactly how it started. Someone just happened to notice the numbers jumping. A chair rolls closer. Another engineer leans in to squint at the monitor. A third person literally stops mid-stride in the hallway because what was scrolling down that screen wasn't normal. It was a massive, fast-growing list of vulnerabilities, dozens of them, and then dozens more. The sheer volume of bugs being flagged in real time left these seasoned engineers in absolute disbelief.
And that shock? It made its way right up the chain of command. The CTO wanders into the room, coffee in hand, probably expecting a totally routine briefing. Instead, he glances at this massive wall of findings, and he literally stops mid-sip. His eyes widen, and he asks, "Is this real?" A security lead actually had to look at him and confirm, yes, it was real. And even more incredibly, it was entirely machine-discovered. Humans were just there verifying it.
Now, the specific nature of what was pouring in was mind-blowing. We aren't talking about simple little typos in the code here. We're talking deep kernel issues, legacy parser flaws, incredibly complex cloud control plane inconsistencies. These are bizarre, ancient, deeply buried architectural flaws. Human teams, they simply couldn't have spotted these at this sheer scale. It was physically, literally impossible for a manual review to catch all of this simultaneously.
So, you're probably wondering, what was actually doing all this finding? Well, it was their M- and Codex-based scanners. And listen, this wasn't just your standard off-the-shelf antivirus scan. This was Microsoft's internal swarm of AI agents combined with OpenAI's Codex models. This swarm was running continuously 24/7. And they weren't just searching for text strings. These tireless agents were recursively reasoning through the codebase. They don't get bored, they don't need a coffee break, they just keep digging. When faced with this absolute mountain of vulnerabilities, the initial human reaction was, honestly, a lot of guilt. One staffer was like, "Man, there is no way we missed all this." But a senior engineer jumped in and corrected him with this really profound realization. He said, "We didn't miss it. We just never had the tools to see it." So this wasn't a story about human failure or negligence at all. Actually, scratch that. It was the exact opposite. It was a story about a massive technological breakthrough in visibility.
So here is the absolute kicker. For the very first time in the company's entire history, the codebase had effectively begun to audit itself. When the room realized this, it just felt completely quiet. It wasn't panic and it wasn't fear, it was awe. History was literally being made right there on that dashboard because the software had woken up and started pointing out its own flaws.
Which brings us to our first major shift, the human-machine loop.
Find, fix, find, fix. This relentless warp-speed rhythm is what defines this new era. Look, discovering thousands of bugs is one thing, right? But to actually manage fixing them without completely collapsing your entire engineering department, you need a totally new operational rhythm. The loop itself is simple, but it is totally relentless. Because the AI machines never, ever get tired of finding, the human engineers never run out of work fixing.
Managing an AI swarm like this, it requires an absolute masterclass in human choreography. At the top level, you've got the tiger teams. They're handling the strange, ancient bugs, the really deep kernel stuff. They need what the source calls archaeological patience, to trace flaws through literally 20 years of code sediment. Then, right in the middle, you have the product teams. They're handling the modern layers like cloud services and Teams integrations, and they fold these AI-flagged issues neatly into fast sprint cycles at warp speed. And finally, security engineering sits right at the center of the storm. They coordinate the whole shebang, tune the scanners, and decide what's just a theoretical curiosity versus what's an actual, real-world crisis.
Now let's zoom out a bit for part 2, mapping the codebase landscape.
To really grasp the mechanics of this, we need to look at the big picture. This event forced a fundamental, philosophical shift in how developers view massive, aging software systems. For decades, Microsoft's codebase has been growing, stretching all the way back to the 1990s. We're talking layers upon layers of history, architecture, and old assumptions. And every engineer knows this one fundamental truth. The system is simply too large, too old, and way too interconnected. No single human,
No single team, and frankly, no single division understands all of it. It's like a giant puzzle where no one has the box cover.
But overnight, that entire view changed. The old paradigm treated codebases as these living fossils, massive, untouchable monoliths where you only ever did reactive patching when something inevitably broke. But the new paradigm? With AI, the codebase is suddenly a mappable landscape. It can be endlessly explored, continuously scanned, and proactively repaired by systems that can see patterns we humans just cannot see. It is quite literally the difference between blindly patching holes in the dark and suddenly having a fully illuminated 3D map of your entire system.
And that brings us to our final section, the future of software repair.
So what does this all mean for us? This planetary-scale audit inside Microsoft isn't just some cool internal victory. It has massive implications for every single stakeholder in the tech industry, and the entire defensive posture is shifting. For Windows admins, it means proactive repair, way fewer catastrophic surprises, because the OS is continuously repairing itself in the background. For Azure customers, it means cloud control plane vulnerabilities are caught long before attackers can weaponize them. Developers, they get continuously hardened foundations for their apps. And for enterprises overall, the attack surface is finally shrinking faster than adversaries can expand it. That is huge.
The absolutely crucial takeaway from this explainer is what we're calling the industrialization of software repair. We are stepping into a brand new world, guys. It's the dawn of an era where software is still written by humans, sure, but it is continuously scanned, continuously understood, and continuously maintained by machines.
Microsoft became the first company to run AI across a legacy codebase of this massive scale, sparking the absolute largest multi-product patch wave in their entire history. And to think, it all started so quietly, on a Tuesday, in a dashboard, with a whisper. Someone just said, wow, and everything changed.
Once you see what the machines can actually find, you simply cannot go back to the old way of doing things. Every major vendor, every cloud platform, and every enterprise is going to have to follow this self-auditing model. So I want to leave you with this final thought to ponder today. As this exact capability scales across the entire industry, what happens when all software ultimately builds and repairs itself? Thanks so much for joining me on this explainer, and remember, keep questioning the code around you.